Hello, in this video I'm going to explain eddy currents. I think it's Eddy. I think it's eddy currents. Which we kind of went over again already. All this is derived from Faraday's law, but I'm just going to keep going through with this stuff. And essentially, an EMF and current are induced in a circuit when you have a changing magnetic flux. So loop, flux comes in, north, south, flux comes in. There's then going to be a current created going one direction or the other direction. Well, if we have a sheet of paper and we have a change in flux, there's some coming out, there will also be a current created on the sheet of paper. Or not sheet of paper, but a sheet of metal. Or any other chunk of metal. So this is basically how brakes work on a roller coaster. So say we have, a magnet right here, and this is north, and this is south. So we have field lines going this way. And then we add a sheet going with this velocity in this direction. And if you, use your right hand rule, you'll have the velocity or the magnetic field of your thumb. So if we draw your hand, again, terrible drawing, my bad. Okay, so then you have your magnetic field, and then you'll have the velocity going in this direction, and the force will be in this direction. Oh, whoops. The magnetic force will be in this direction. Because really that sheet of copper is a bunch of charges moving through that field. So because of that, if you're, say, putting it in that direction, you'll get a current formed like this. I'm going to use a different color. You're going to get a current formed like this. The current will be in the opposite direction of motion if you're getting it to go through a magnetic field in this instance. And then once it's past the midway point, so this is past, I'm going to take it out. This is past the midway point. You're actually going to get the velocity will still be in the same direction, most likely. But you're going to get an opposite current on the sheet of paper. So I'm going to draw the force lines real quick. We're going to have force be red. So then the force will be in this direction. And the force will be in this direction. This is because as you pass through the middle, it's still going to want to resist the change in flux. There's still going to be these field lines going through it, and it's not going to want to maintain it. It's going to want to stay the same, so it's going to resist that change. It always resists the change. So you're getting an EMF, which in turn will induce which divided by the resistance on the plate will also equal a current running in that plate, which will give you eventually a force when you work through all the different equations I'm not going to go through. You can look at previous videos. And which is essentially, this squared. So it creates a force opposing that velocity. That's basically all that is. And that force will slow down things, obviously, because you're applying a work in the opposite direction of motion. You're going to slow it down. So take, for example, a roller coaster riding in this direction at the velocity. If you have a force applied over, a specific distance, you're going to get a lower velocity because you're having a mass times acceleration in the opposite direction. I thought it was really simple to understand. Same idea, except for now we're applying it to not a circuit, but a just piece of metal flying through a magnetic field. But it's the same basic concept. There's going to be a movement of the electrons and the free particles to create a magnetic field to oppose the magnetic field that the magnetic flux, the change in magnetic flux that it's experiencing, which then creates a force. Anyways, I hope that helps. Feel free to comment. I'll answer any questions. If you need another video, maybe an example video, I'll create one. But until I see interest, I'm not going to create one. Thank you for your time.